Hello students, welcome to Unit 9 Notes, Section 10.7 of our distance learning. If you would like to pause it here to do the warm-up, you can. It was just conversion between radius and diameter and circumference, diameter, circumference, and radius. All right, so 10.7 is areas of sectors, circles and sectors. This one will go much quicker, this lesson. So there are sectors and there are segments of a circle. So here is the area of an entire circle. Area, the area formula is pi r squared. It's in squared units because we're going to square the radius, and it's about 3 portions of them, 3.14 portions of them. So it makes sense that it would be squared units. Now the area of a sector, this is called a sector. It's what you see shaded. It's not the whole circle, but it's part of it. Kind of like we did arc length before, we're now going to do sector area. So how do we do it? It's very, very similar to arc length. The area of a sector is theta over 360 times, not circumference, but instead area. So to simplify it, we're going to do sector area is equal to theta over 360 times pi r squared. Okay, we'll do a quick example. This looks like maybe it's I don't know, 120 degrees. I'm going to make that up with a 6 centimeter radius. So sector area is going to be theta over 360, so it's going to be 120 degrees over 360 times pi 6 centimeters squared. Okay? If this wasn't a sector and it was just area, it would be that. Area equals pi r squared. But we have to account for the rest of it. So sector area is 1/3 times pi. 6 times 6 is 36. Centimeters times centimeters is centimeters squared. So sector area is 36 pi over 3 centimeters squared. So sector area is 12 pi centimeters squared. Now, in a full circle, you actually do 360 over 360. So you just have 1. So really, we're using the sector area formula for an entire circle when we do this area of an entire circle. This is just 360 over 360, making it 1. So 1 times pi r squared. So with the same circle above, your area is simply just pi r squared. So area is pi 6 centimeters squared. So area is 36 pi centimeters squared. And that's how they differ. All right. Now, the only other thing you have to know about this is how to find the area of a segment. So a segment, so that was our sector area, but our segment is this piece right here. It's almost like if I took a pizza and just kind of like cut it, but I didn't cut it down the middle. I mean, in theory, down the middle is a sector that is perfect. It's called a semicircle. But if I cut it a little bit off, then what I have to do first is I have to figure out, well, how much of it is it? So I got to kind of work backwards and come to the center. And I always take away a triangle. So find segment area. I'm sorry, find the ratio of the, what am I doing? Okay, sector. I keep using the wrong terminology. I'm sorry. So take your sector area take away your triangle, and that will be equal to your segment area. You'll do that each time, you just have to make a triangle. All right, so there's your sector. Take away the triangle. Now, why they didn't connect it, that's a really bad drawing. This should be from here to here. Don't get confused. I don't know why they did that. Can I cover that up? Okay. That didn't work. One more time, let's try that again. There we go. Maybe I can cover that up. Not too bad. There we go. That was a mess up on the textbook. So that's what it should look like. And you know what? To make it more consistent, let's change that style to like a grayish. Okay. Good. So you are going to take your sector area, take away the triangle, and then that will leave you with the area of the segment. Some of these can be difficult. We're not going to spend too much time on them, but let's do all three examples. Let's do segment, sector, and then regular area as well. So here, how much more pizza is in a 12-inch diameter pizza than a 10-inch? So let me draw two pizzas. Okay, that was supposed to be a circle. There we go. Going to draw a diameter. And it's 12, but let's say it's 6 inches and 6 inches because the radius is split in two. So now what I'm going to do is I'm going to copy paste this. This one is a 5. And 5 because it's 10. So it says how much more pizza is in a 12-inch diameter than a 10-inch. So I just want to show you visually that's really a 6 and a 5 when we're dealing with the radius. So area always has to be based on the radius. You don't have a choice. Where circumference, you could do radius or diameter. So area equals pi r squared. Area equals pi 6 inches squared. Area equals 36 pi inches squared. Then we're going to do the area of a smaller one, which is literally all the same thing. I'm going to save time here. I'm going to do that. I'm going to change it to orange. It's not 5. It's not 6, it's 5. So it's going to be 25 pi. How much more? So you're going to do the area of the larger minus the area of the smaller. So area of large. You know, let me clean that up. Area of large. Take away area of small. So we're going to do 36 pi inches squared. Take away 25 pi inches squared, which is 11 pi inches squared. So 36 minus 25, yes, is 11 times pi. Now, we probably don't want to leave it in terms of pi. We want to leave in terms of pi while we're manipulating it and finding the difference between both of them. But we don't want to, we want to leave it because we're talking about pizza. We kind of want to convert it. So we're going to say this is approximately equal to 34.5 34.575, which is approximately 34.6 inches squared. So we're going to say there's approximately 34.6 inches squared more pizza in the large we'll say in the, we don't know if it's a large, but I think that's how they define large. Whoops. Let's say in the 12-inch diameter pizza than the 10-inch. It's good enough. Call that a day. Okay, next problem. How much more pizza is in a 14-inch than a 12-inch? So, to save time, literally going to copy and paste. So 14, I'm going to change these. So 14 is going to be 7 and 7. And then this will be 6 and 6. So we'll do all of that's going to go. And these are inches. So yep, okay. Literally, this should be pretty quick for me to type in all this stuff. So it's going to be 7 inches squared, which will be 49 pi. This one will be 6, which will be 36. So now it will be 49 pi minus 36. And that is 13 pi, right? 13, yep, 13 pi. So 13 pi 40.84. Let's just 40.84. Which is about 40.8. Let's just round down. Inches squared. And we'll just change this to change that, change that, change that. So 40.8 inches squared more pizza in the 14-inch than in the 12-inch. Cool. As you can see, it's increasing as it gets larger. I think we did everything right, even though I did it really fast. Yeah, it looks good. Okay. Next one, we want to know the sector area of this one. So sector area is pi r squared, but it's not just area, so we're going to do 360 theta over 360 times pi r squared. So sector area equals 72 degrees over 360 times pi r is 20 centimeters squared. Wants me to leave my answer in terms of pi, so I want to make sure that I don't approximate this and that I simplify it. I wonder, 72 is divisible by 9, and 360 is divisible by 9. I can divide them both further. You know what? They're both divisible by 36. Actually, 360 is divisible by 72. Wow. So what I can do is I can divide both by 72. So what I'm going to do is say SA, sector area is equal to 1 over 5, because that's what 72 divided by 360 equals, times pi, and this becomes 20 times 20 is 400 centimeters squared. So I get sector area is equal to 400 pi centimeters squared over 5, which is 80. So sector area is 80 pi centimeters squared. All right. Another way of looking at this, just to give you a heads up, sometimes you'll see it written this way: area of sector equals 80 pi centimeters squared. It's called subscript. It's used a lot in mathematics along with physics and like different sciences. But it could be a subscript or it could be in parentheses. So like area, parenthesis, sector, close parenthesis. So there's a couple ways of looking at that. Okay. Next one, a circle has a diameter of 20 centimeters. What is the area of the sector bounded by a 208-degree major arc? Round your answer to the nearest tenth. This one will be nice because we can round. So round to the nearest tenth. Now just be careful. Diameter means that you have a radius of 10 centimeters. So we have sector area. Let's use, so sector area equals theta over 360 times pi r squared. So sector area equals, we are doing 208 degrees over 360 degrees times pi r, what's r? R is 10 centimeters. Because I'm able to round this, I'm going to do all of this together. So I'm going to do, let me do 208. I'm not even going to try to simplify this other than my degrees over degrees. I'll say times 100 centimeters squared, because that's my radius squared. I messed this up. Squared supposed to be on the outside because I'm squaring the 10 and squaring the centimeters. So 10 squared is 100, centimeters squared is centimeters squared. So 100 times, what I'm going to get here is sector area equals 20800 pi centimeters squared over 360. And I'm going to multiply that. So 20800 times pi equals divided by 360 equals, and I get sector area. Sector area approximately equals 181.51424. So sector area approximately equals 181.5 rounded centimeters squared. And that's it. Okay, I think we have one more slide left and then I'm done. We're going to find the area of a segment. So this one you have to take away your triangle, don't forget. So looks like we have a radius of 10 and it looks like it has 90 degrees. So this one might not be too bad. So sector area is what we have to first find. So it's going to be theta over 360 times pi r squared. So sector area equals 90 over 360 times pi 10. Yeah, 10 inches squared. Sector area is 1/4 because 90 over 360 will simplify to 1/4 times pi 100 inches squared. And so 100 divided by 4 is 25. So sector area is 25 pi. 100 divided by 4 is 25 pi inches squared. Leave it in terms of pi for now. So now the area of my triangle, area of triangle is equal to 1/2 base times height. Area of the triangle is equal to 1/2 10 inches times 10 inches. So area of the triangle is half of 100 inches squared. So area of the triangle is 50 inches squared. And now at this moment, you can find the area of your segment. Okay, I used up a lot of room here. Let me try to save some. Whoops. Okay, so now the last one, it's going to be area of sector. Area of segment. Equals, it's going to be the sector, which is 25 pi, area of segment equals 25 pi inches squared minus 50 inches squared. And so 25 pi minus 50. So it's about, which is about 28.539816. So it says the nearest tenth. So area of the area of the segment, I'm using the other notation as you can see. It's approximately equal to nearest tenth is 28.5 inches squared. And we're done with that problem. All right, one last one. A circle has a radius of 12 centimeters. Find the area of the smaller segment of the circle determined by a 60-degree arc. Round your answer to the nearest segment. So, circle has a radius of 12 centimeters. I don't think I want to do this one with you all because if it's determined by an arc that's 60, this is going to involve a 30, 60, 90 triangle. So let's say that we are going to skip this one. Skip because of 30, 60, 90s. Okay, and I don't think you have any in your homework. You do. Find the area of the round. The answer let's leave, yeah, because I don't want you doing 30, 60, 90s. Let's skip these. 17 and 19 you can skip. Okay. And skip 23 and 24. And that should be good. Okay. The only other thing you're going to need is to use the Pythagorean theorem to find out that this one is 60 feet, that radius is 60 feet right there. Okay. But other than that, I think you are good. You should be able to do all those. Okay. Alrighty. So don't forget to do your IXL assignments as well. Those are the ones that are graded, but this is extra practice. Okay. Good luck.